All right, grade 12. Here we go. We're going to start our study of electric forces, similar to what we did in grade 10, but just a bit of a review. So the aim of this first video is to try to do some study of electric forces using some example problems. And the aims of this video is to understand what is static electricity, to explain the mechanism of charging by friction, and to explain the mechanism of charging by induction. So we're not going to do any calculations, we're just going to explain how things become charged. So the first thing is, why do insulators often carry static electricity? Well, we have two different types of objects, okay? We have, for example, an insulator, which is usually plastic or wood, okay? Things that are non-metals. And conductors, okay, I'm going to make that shiny conductor, okay? Let's say that that's a conductor, and that conductor is made of metal. Well, insulators often carry static electricity. What static electricity means is it means electricity that does not move. Well, what is electricity? Electricity is charge. It's the flow of charge. So in this case, on an insulator, we have electricity that doesn't move. And that's generated by adding extra electrons onto the surface of an insulator. On the other hand, I can remove electrons and make it positively charged, but that's a different story. But here we see that that insulator is carrying extra electrons. Well, why doesn't a metal often carry extra electrons? Well, usually because somebody is holding on to it, okay? So somebody is standing and holding on to that, and they're attached to the ground. So as soon as we put an electron on it, a conductor allows electrons to move. There is a sea of electrons around that metal that are constantly moving, okay? They're moving in all directions. So when you put an electron, that electron's going to repel that sea of electrons, and it's going to move into you and down into the earth. So electrons don't often sit static in a conductor. However, in an insulator, these electrons are not able to move around. They're stuck. So insulators gather charge and become charged objects, and they'll carry static electricity. And what's the effect of having static electricity? Well, you can start to attract objects from the ground onto that plastic. Okay, so plastic wrap, if you remove it and you rub it around or you rub it on your hair, will pick up extra electrons, become charged, and start to interact with other charges. So in this little question, we learned a little bit about insulators and conductors and what are the differences. All right, so what charge does a plastic rod, which is an insulator, become when it is rubbed with fur? Okay, so if I have my plastic, this is plastic, okay, and let's say that this is a tail of an animal, okay, it's fur, all right, and if I rub that plastic with fur, what's going to happen is electrons from the fur are going to hop onto the plastic. So what charge does it become? It becomes negative, okay, and the longer that I rub it, the more electrons are going to go onto that plastic, okay. The rubbing causes friction. Friction between the surfaces provides energy for the electrons to hop from the fur to the plastic, and it stays there because plastic is an insulator, okay. This is something you need to remember. When you rub fur on plastic, it becomes negatively charged. That's an IB question, okay. What charge does a glass rod become when it's rubbed with silk? Well, in this case, it's the opposite. When I take a piece of silk fabric and I rub the glass rod, okay, glass is quite electron rich. Electrons from the glass are going to move to the silk, leaving a positively charged glass rod, okay? That's important, okay? So that's two different ways that we can generate charged objects. I can rub plastic with fur or amber and make it negatively charged, or I can rub glass with silk and make it positively charged. You need to know this because it could show up on an exam with those examples. Often ways that we can charge things in different charges. So explain why neutral paper becomes attracted to charged objects, okay? Well, neutral paper has an equal number of protons okay, and electrons. Electrons are all around those protons. For every number of protons I have an equal number of electrons, which means that that paper is neutral. Okay, and from your reading, you would have learned about the charge carrying electrons and the protons. So you know that those are the particles that give materials charge. So this paper object is neutral. So why would a neutral object such as paper be attracted, for example, to a positively charged glass rod? How can that attraction happen? I don't see it. I understand that attraction happens when an object is opposite charges. If that paper was negative and the glass was positive, they should attract. But why is it that when I bring that object close together, we get attraction? Okay, that paper is going to hop from the ground onto the surface of that glass. Why does that happen? And that happens by a phenomenon called induction. So let's just take a look. If I bring this positively charged rod close to a material, this is actually a metal material, but if I bring it close to that material, what's going to happen is that positively charged rod is going to attract the electrons towards it. So this side of that material is going to become negatively charged, while that side becomes positively charged. And that side of the material now is going to attract. Okay, so if I change the color here, that's going to attract. So you'll see that as we get close, it's going to attract. And in this case, you might get a zap because those electrons are going to hop to the rod. Okay, but in this case, if I have a glass rod that's positive, and I have little bits of paper on the ground, okay, as I bring it close, as I bring that rod close, what's going to happen is I'll get negatively charged surface on that paper, and that's going to cause it to attract. All right, so what's going to happen is that paper is going to jump up and stick to the surface of that rod. And that's called charging by induction. We're not touching it, so we're not moving charge by conduction, like in these cases, those were conducting charge. Here, I am charging a surface by induction through space. That space is causing charges to move.